Okay, so today we're going to continue with the review chapter. We're still in section 3 of the review chapter. Today we're going to learn how to multiply polynomials. So when we're multiplying polynomials, essentially what we're doing is using the distributive property. So when I go to do this first problem, what I need to do is take each term of this first binomial and distribute it to the 3 terms in the trinomial. And then I'm also going to take the second term, and again I'm going to treat this as a -4, and I'm going to distribute it to the 3 terms. So essentially I could change my problem and say, really what I'm doing here is 3x times 2x squared minus 3x plus 5. And then it sort of looks like the problem that I did yesterday. Now, for those of you who can already see that you're going to distribute the 3x to that second trinomial and the -4, you don't need to rewrite it this way. But I just want to clarify that each of the terms of that first binomial are going to get distributed to the trinomial. So let's go ahead and I will distribute each term. So for the red, 3x times 2x squared is going to, I multiply the coefficients, so 3 times 2. Remember on this 3x, I can assume it has an exponent of 1. Remember when you multiply variables that have the same base, we add the exponents. So this will become 6x to the 3rd power. I'm then going to distribute the 3x to the -3x, giving me -9x squared. And then I'll distribute the 3x to the 5, giving me +15x. Remember, when you multiply terms, they don't need to have the same variable. They don't need to be like terms. That's only when you add and subtract. Now I'm going to work on the blue portion, and I'm going to distribute the -4. So -4 times 2 is -8x squared. -4 times -3 gives me +12x. And then lastly, -4 times +5 is -20. Now that I've gotten rid of the parentheses and I've multiplied, now I go back and combine my like terms. And this is where we're looking for exactly the same exponent in order for the terms to be like. So notice there are no x cubed terms or no x to the 3rd, so I'm just going to rewrite the 6x to the 3rd. Then I'm going to go back and look for all of my x squared terms. I have a -9x squared and a -8. So I'll add the coefficients. -9 plus -8 gives me -17. And then I'll go back and add the x's. +15 plus 12 is +27x. And then there are no constants to group with that -20, so I'll just rewrite it. My final answer is in standard form. It is in from greatest to least of exponents. Everybody good on this example? Any questions? Let's try another one. Now, this time, I'm going to be multiplying 2 trinomials, but the process is the same. I'm going to take each term of this first trinomial, and I'm going to distribute it to the 3 terms here. So again, I could say it's 3p squared, and then I'm going to distribute it to the p cubed plus 2p minus 8. Then the second term here, the -4p, will also distribute. So again, I could write it as -4p, rewrite that other trinomial, and then lastly, the +1 will also get distributed. All right, so I'll go ahead and distribute the red. So again, remember when you're multiplying two bases that have, or two exponents that have the same base, you add the exponents. So 3p squared times p to the third. I will add those exponents on the p's. So it becomes 3p to the fifth. And then now when I go to 3p squared times 2p, 3 times 2 is 6. And again, you can assume this has a 1. So this becomes p to the third. And now 3p squared times negative 8 gives me negative 24 p squared. Now I'll move to the blue. Negative 4p times p to the third gives me negative 4p to the fourth. Negative 4p to the 2p is going to give me negative 8 p squared. Negative 4p times negative 8, negative times a negative, gives me positive 32p. Now we'll go to the green. 1 times anything is just itself, so I'm just going to rewrite that trinomial. P to the third plus 2p minus 8. Now that I've gotten rid of the parentheses and I've multiplied, now I'm going to go back and add my like terms. So again, I'm going to look for I'm going to look for the greatest exponent first, which is p to the fifth. There is not anything to add to my 3p to the fifth, so I'm just going to rewrite it. Next, I'm going to look for any p to the fourth powers. I have just that one, so all I'll do is rewrite it with the sign that's in front. Then I'm going to look for my p to the thirds. I have one here, and I have another one right here. Again, remember, you're assuming that there's a 1 in front of this green p to the third. So 6 plus 1 is 7, p to the third. Next, I'm going to look for my p squareds. I have a negative 24 here, a negative 8, and then a positive, that's it, just those two. So negative 24 plus negative 8 gives me negative 32p squared. Now I'm going to go back and look for all my p terms. And I have a 32 and a 2. 32 plus 2 is 34. And now I'll go back and look for any constants I have. So I only have one constant. It's down here on the end, and it's the negative 8. Nothing to group with it. My final answer is written in standard form. Everybody good? Anybody still need it? All right. The next thing we're going to talk about now, technically, when you're multiplying two binomials, you don't need to use this acronym. This is just a little study tip or way to make sure that you're covering everything. It's just a little memory aid. So when you multiply two binomials, you don't need to use FOIL. You can use distributive property. But essentially, this little memory aid is giving you a little clue of what to do for distributive property. So the memory aid is called FOIL. And the letters of the word FOIL, the F stands for the word first, so the two first terms. The O in FOIL stands for outside or outer, and the I in FOIL stands for inside or inner, and then the L in FOIL stands for last. So it tells you the pairs of terms to be multiplied together. So for example, the first term in each of the binomials is going to be the 6m and the 4m. So when you multiply those two together, 6m times 4m gives you the 24m squared. And then if you do the two outer ones, you're doing the blue here. So the two outer ones on the outer edges would be 6m times negative 3, and that's how they got the negative 18. And then the two inner ones, 1 times 4m, and you get positive 4m. And then the two last terms, which are going to be the positive 1 and the negative 3, you get negative 3. Whenever you multiply two binomials together, those two middle terms generally can be combined, and it'll turn into one term. Or it even cancels out in the case of the difference of two squares. And we're going to be seeing the patterns coming up. So once I combined the blue and the green here, it turned into negative 14m. Now, again, if you don't like to FOIL, you can just do distributive property. So if I took the same problem, 6m plus 1, 4m minus 3, and if I just, again, do distributive property, I'm going to say the 6m is going to get distributed to the 4m minus 3, and then the positive 1 also gets distributed. You can also think of it that way, or just distribute. So then 24m squared minus 18m plus 4m minus 3. Notice I got the exact same thing just by doing distributive property as when I use that little memory aid of FOIL. Combine those middle ones, and you get negative 14m minus 3. So FOIL is just a little memory aid to help you remember which terms to multiply. So now we're going to practice using this distributive property and FOILing if you want to use that. So here's the first example. Again, I am going to distribute or FOIL. So my first ones, or if I distribute the 6m to the 4m, gives me 24m squared. And then the 6m to the negative 1. And now the 1 to the 4. And the 1 to the negative 1. Again, group your middle terms. Negative 2m. And then just rewrite the rest of the problem. 24m squared minus 1. Yes? All right, let's try the next one. Now, this is one of the special cases. Notice that they have exactly the same letters and numbers. The only difference is the first binomial is an addition, and the second one is a subtraction. Once I distribute this or FOIL this, I'm going to end up with a special case, and it's called the difference of two squares, or the difference of two perfect squares. So again, if you're just distributing, you're going to distribute the 2x to the 2x, 2x to the negative 7. Again, this could be also described as FOIL. 2x times negative 7 is negative 14x. Then we'll go to the 7. It distributes there, which is also inner. And then finally, the two last is negative 49. Notice when I go to group my middle terms, negative 14 plus 14, they're gone. It's 0. So my final answer here is 4x squared minus 49. This pattern is called the difference of two squares. Because when you factor this, which will be coming up tomorrow, it turns into these two types of binomials with the same numbers, but one's a plus sign, one's a minus sign. Here's another set of two binomials. And again, either use FOIL or distributive property. So again, I would multiply the 5 to the 3m first, and that gives me 15m squared. Again, remember, you assume a 1, and we're adding those exponents. Then we would multiply the 5m to the 4, which gives me 20m. And now the negative 6 to the 3, and the negative 6 to the 4. Again, group the middle terms. So the final answer here is 15m squared plus 2m minus 24. Okay, so yesterday I told you Algebra 2 has lots of fractions. Do not be intimidated or afraid of the fractions. Okay, so we'll become really good at working with fractions. So again, same thing here, even though they're fractions, I'm going to distribute the 2m to the 3m. 2m times 3m is 6m squared. Then I'll distribute the 2m to the 1/2. And again, if you need to give yourself a visual, make the whole number 2, 2 over 1 times 1 over 2. This gives me 2 over 2. I can also simplify before I multiply, which is just 1m. And then I'll distribute the 1/4, and it's a negative 1/4. So negative 1/4 times 3 over 1 gives me negative 3/4 m. And then negative 1/4 times 1/2. 1 times 1, and then 4 times 2, and it's negative 1/8. I now need to combine the middle terms. These are like. So again, remember when you add and subtract fractions, you need to find a common denominator. Now, to turn my whole number, I can just look at the fractions denominator that I'm trying to subtract, and I can make that whole number 1 into 4 over 4. And then I can subtract it and get 1/4. So final answer here is 6m squared plus 1/4 m minus 1/8. Everybody good on these two? All right, let's try another one. Now, remember yesterday when we talked about exponents, and I gave you only monomials or just a single term yesterday. Now we're dealing with binomials, trinomials. So yesterday, remember when we saw that product of a power and you had something like 2x squared that was raised to say, or let's make this to the 4th, and it was squared. Remember that 2 went to the 2 and to the 4. So this would have really become 2 squared times, and then the power to the power. Whenever you have a binomial or a trinomial squared, you can't just take this 2 and square that and square that. We need to actually write this 2 times and then distribute it. So for example, this could really also mean 2m plus 5 times 2m plus 5. The common answer mistakes that I'm going to see on the quiz or on the test are people are just going to say, it's 4m squared plus 25. By just putting the power of 2 on both of those, you're missing the middle term. So be very careful when you get questions and you have a binomial squared or a trinomial, you're writing it that many times. Now, there is a pattern to this, and we're going to see that when we factor, but for now, we're going to write it 2 times, and then we're going to distribute. So again, you're going to take the 2m, it'll distribute to that 2m and to the 5. So 2m, and again, we can FOIL here. Either way, however you want to describe it. So 2m times 2m gives me 4m squared. 2m times 5 is 10m. And now I'm going to distribute the 5 to the 2m and the 5 to the 25. Again, I have 2 middle terms that can be grouped together. They are like terms. So final answer here, 4m squared plus 20m plus 25. So whenever you see a binomial squared, you're going to write it twice and distribute or FOIL it. Don't just put that power of 2 on each of the terms. You will get it wrong because you're going to miss out on that middle term. The next example, all we're going to do is distribute this 2x cubed to each one of the terms. So this one would become 2x to the 5th power. We are adding those exponents of 3 and 2. 2x times negative 4. 2x cubed times negative 4 is negative 8x to the 4th. Again, assume a power of 1. And then lastly, 2x cubed times 3 is 6x cubed. Notice again, it's in standard form, greatest to least of exponents. Next example. Again, notice all of the numbers and the letters in my problem here, or my question. They're the same, the only difference is the sign in between the terms. Again, this should be a clue to you that when you're done, this is only going to result in 2 terms in your answer, the difference of 2 squares, because that middle term is going to cancel out. So let's watch it. So we're going to distribute the 8s to the 8s and the 8s to the 3t. Once I do 8s times 8s, I get 64s squared. And again, be careful with the s's. Make sure you're writing nice and neatly so you don't think it's a 5. And then 8s times 3t, I get 24st. Now, whenever I'm multiplying 2 letters, I like to write my letters in alphabetical order, ABC order. That way, it's easy for me to see like terms. So notice I put it ST, because watch what happens now when I distribute the negative 3t to the 8s. You might think, I'm going to write it as 24ts, but then you might not realize that these two are like terms. So when I go to write my answer, I'm going to write it again in alphabetical order. So I'm going to write my variables as negative 24st. So I'm just going to flip-flop it. You might, be tempted to write it as ts, but again, it makes it easier for me to see the like terms. And then lastly, I'm going to distribute the negative 3 to the positive 3t, and I get negative 9t squared. And just like I said at the beginning, when we go to simplify the final answer, this middle term will cancel out because positive 24 minus 24 becomes 0. So 64s squared minus 9t squared. Both of these numbers are perfect squares. So I don't know if you remember back from Algebra 1, but perfect squares are like when you square a number, like 1 times 1 is 1, 2 times 2, 4. So 1, 4, 9, 16, 25, 36, those are all examples of perfect squares. So 64 comes out from 8 times 8, and 9 comes from the 3 times 3. All right, the next one, again, difference of 2 squares is going to be my final answer, but we'll go ahead and distribute here, or FOIL. So again, we would take the 2m to the 3rd power, multiply it to the 2m to the 3rd power. 2 times 2 is 4. Add the exponents, 3 plus 3 is 6. Then the 2m to the 3rd will now get also multiplied to the negative n. So negative 2m to the 3rd n. And again, I'm writing it in alphabetical order, just so I can see my like terms a little bit easier. And then I'm also going to distribute the n to the 2m to the 3rd, giving me positive 2m to the 3rd n. And then lastly, n to negative n gives me negative n squared. Again, my middle terms, notice they are opposites, so they cancel. Final answer, 4m to the 6th minus n squared. multiplying coming back. All this foiling and distributing. All right, we'll do 3 more examples and I'll take any questions. Everyone good on this slide? Let's try another one. Okay, again, we have a binomial squared. Again, you can't just put that exponent of 2 on the A and on the negative 6b. I am going to write this 2 times and distribute. So again, the A gets multiplied to the A and to the negative 6b. So A squared minus 6ab, again, I'm writing it in alphabetical order. Instead of putting BA, I put AB, alphabetical order. And then next I'll distribute the negative 6b to the A. So again, I'm going to write this as negative 6ab. And then negative 6b to negative 6b. Negative times negative is positive 36b squared. Again, remember all of these variables that were here had exponents of 1 that you could assume. Now, when it's a binomial squared, you do get a middle term. So we would do a squared, add those 2 middle terms, negative 12ab plus 36b squared. This example is the same thing. I can't just put that power of 2 on each term because it's got an addition or subtraction sign. When it's a monomial and there's no plus or minus signs, you just put that power on each thing. But when it's something like this, you write it however many times that exponent is, and then you multiply it or distribute it. So 2z to the 4th, 3y, I'm writing it twice. Again, be careful with those z's, don't think it's a 2. So here I'm going to, again, distribute the 2z to the 4th. This gives me 4z to the 8th. Distribute the 2z to the 4th to the negative 3y, which will give me negative 6. Again, I'll put it in alphabetical order. So at the end of the alphabet, X, Y, Z. So I can write this as, and again, it doesn't matter. If you decided to put Z to the 4th first and then the Y, that's fine. Just stay consistent. So I'm just putting mine in alphabetical order. So then next, negative 3y, distribute here and here. So then this gives me negative 6y, z to the 4th. And then lastly, positive 9y squared. Again, the middle terms can be grouped, giving me a negative 12. Negative 12, y, z to the 4th, and then drop down the red and the blue. So like I had said before, you could also have written your answer as 4z to the 8th minus 12z to the 4th y plus 9y squared. So you could flip-flop the letters. It doesn't matter. Now, when you're writing things in standard form and there's more than one letter, just pick a letter and then put it in standard form from there. My answer is in standard form based on the z. If you would have put the 9y squared first, that middle term would have stayed the same, and then you could have flip-flopped these. But I just picked the largest exponent and FOILed it or distributed it from there. We have one more example. And again, this is sort of similar to what we did last night. All we're going to do is distribute the 2 to all 3 terms of this trinomial. Again, treat this as a negative 3 that you're going to distribute. and then we're gonna combine like terms. So let me just rewrite it here to show that I'm gonna distribute this one first, and then this one will get multiplied. All right, so for the red, 2 times 3x squared gives me 6x squared. 2 times 4x is 8x. 2 times 2 is 4. Now I'll distribute this -3. -3 times -x squared gives me positive 3x squared. And then -3 to the 4x is -12x. And then lastly, -3 times -5 is 15. Now I'll go back, look for like terms. I do have an x squared term. So 6 plus 3 is 9x squared. 8x minus 12x, -4x. And then lastly, 4 plus 15 is 19. So that is multiplication. So again, just distributive property. Again, the common mistakes I see are when it's a binomial squared and students think you can just distribute the exponent. You need to write the binomial twice, or even if it's cubed, you'd write it 3 times and distribute. So your homework is pages 33 and 34, and 35 through 51 odd, 63 through 71 odd. Again, go to the PDF of the chapter review chapter, and then you can either screenshot it. Now this will probably involve a little bit more work, so try not to cram it right in there. If you want to white out the evens, so you could work it next to it, or add a page. When it's going to get too long, I would prefer you add a page and rewrite the question.